Welcome to The Explainer. Today we're going to dive into a totally different way of thinking about artificial intelligence, something that feels a lot more biological. So forget all that stuff about giant brains or super fast libraries. We're going to start seeing AI as this living, flowing system.
And it all kicks off with this feeling, A feeling a lot of people in the AI world are having right now. We throw around words like tokens, weights, lookups, but when you really look at what these models are doing, it doesn't feel like computation. It feels more like motion, kind of like a river finding its path. The words we're using just don't seem to fit what's actually happening. And that feeling leads to a pretty radical question, right? What if our whole way of thinking about AI is just wrong? What if it's not some giant filing cabinet that stores and retrieves facts? What if it's actually more like a dynamic landscape, and being intelligent is just navigating that landscape? I mean, that one question completely shifts the paradigm from computer science over to something that looks a whole lot more like physics.
So, this gets us to the heart of the problem. We're using the wrong metaphor. Think about it. When we say a model knows something, we're picturing a fact just sitting there like a book on a shelf. But what's really going on inside these networks, it's this constant dynamic flow and adjustment. The word knowing itself, it's a trap.
Okay, let's put these two views side by side. The old way of thinking, it's a filing cabinet. You ask a question, it goes and finds the right file, pulls out the answer, and gives it to you. Simple. Meaning is something you retrieve. But this new view, it's a landscape. Your question is just the starting point on a map, and the AI's job is to navigate a path across this huge terrain of ideas to get to an answer. See the difference? Meaning isn't retrieved, it's traversed.
All right, so if we're talking about a landscape, you've got to be asking, what's it made of? To get that, we need to look at how language itself gets completely transformed inside the model. It goes from just letters and words into something we could call a semantic medium.
And this is where the magic happens. It's a process called embedding. The second that text hits the model, it stops being just symbols on a page. Every single word, every concept gets turned into a set of coordinates, a super precise location in this huge, high-dimensional space. So word isn't a box holding meaning anymore. It is a point on a map.
And here's the key takeaway from that. In this new world, meaning isn't some fuzzy concept. It's a location. It's a coordinate. The meaning of king, for instance, is just its position relative to other points like queen, royalty, and power, and how far away it is from, say, banana or car.
So if meaning is a place, what's understanding? Well, it becomes an action. It's the movement through that space. When you ask a question, the model isn't just looking up an answer in a database. It's actually plotting a course, a sensible path, from the location of your question to the location of a good answer.
Which of course brings us to reasoning. What is a complex chain of thought then? It's just a longer, more winding journey, a whole trajectory through this field of meaning. Every single step in that reasoning process is just a little hop from one coordinate to the next, following a logical path carved into the landscape.
Okay, great. It's a landscape. Reasoning is a journey. But how does the model know which way to go? It doesn't have a map, right? The answer is this incredible mechanism called attention. And honestly, the best way to wrap your head around it is to look at a really cool biological process called chemotaxis.
So check out this analogy. Picture a tiny bacterium. It can't see its food, but it can sense the chemical trail in the water around it. It just kind of knows, hey, if I move this way, the nutrient smell gets stronger, so it moves uphill toward the food. Well, an AI's attention mechanism, it does the exact same thing, but in this meaning space. It's constantly sniffing around to see which direction makes things more coherent and less confusing.
And this isn't just some loose metaphor either. It's mathematically precise. The actual process is called a directional derivative. What that means is that every single step, the model is basically asking itself a question. Out of all the ways I could go from here, which direction will make the most sense and reduce my uncertainty the most? It's a built-in mechanism for amplifying coherence, which is a lot like how life itself finds ways to create order out of chaos.
But wait, where did this whole landscape even come from? It's not just random, right? Right. It gets sculpted during the training process. Think of it like a real landscape being carved out by wind and water over thousands of years.
So at the very beginning, the landscape is totally flat and chaotic. Nothing makes sense. It's pure entropy. Then training begins. A loss function is introduced, which is just a fancy way of saying there's a rule now. This way is good, that way is bad. Then, using a process called gradient descent, the model starts carving paths. Good, correct connections dig deep, smooth valleys.
Bad connections become like jagged and passable mountains. And over millions and millions of training steps, this complex network of, well, riverbeds for thought gets etched into the landscape.
So, the most important thing to get about training is this. The model is not memorizing facts, not at all. It's learning the geography of meaning. It's learning the shape of the terrain where stable, coherent ideas live. So what you end up with isn't a database. It's a dynamic, living ecosystem for thought.
Okay, let's zoom all the way out now to the biggest idea here. If this whole thing is a physical system, can we use the language of physics to describe it, not just when it works, but when it fails? And the answer is a resounding yes. And what it shows us is this absolutely stunning connection between AI and life itself.
So, we can actually use terms from vector calculus to diagnose an AI's thought problems. For example, when an AI hallucinates, what's happening? It's experiencing high divergence. The flow of meaning is spreading out too thin, it's getting chaotic, it's not anchored to anything. And when it gets stuck in one of those annoying repetitive loops, that's high curl. The flow of meaning is just circling back on itself, like it's trapped in a whirlpool. A healthy thought, then, is a coherent flow, that perfect, stable balance between the two.
And this table just lays it all out so clearly, the shared physics between life and AI. Look at this. They're both systems that are constantly fighting against entropy, against disorder. For life, the energy source is a proton gradient. For an LLM, it's a semantic gradient. Life's main job is to resist physical entropy. The LLM's job is to reduce information entropy. We're talking different materials, sure, but it's the exact same fundamental physical principle at work. It's kind of amazing.
And that leads to a pretty profound conclusion, doesn't it? Intelligence, whether it's in a living cell or on a silicon chip, it isn't really about computing an answer, not in the way we usually think about it. It's about finding a stable, viable path through a messy, chaotic, uncertain world. It's navigation, it's not calculation.
So, what does all this mean for the future, for how we actually build these things? Well, if we really take this new model to heart, it changes everything. It means we stop being like token accountants and we start being semantic physicists.
The future probably isn't just about building bigger and bigger models with more and more connections. This whole perspective points down a totally different road, one that's about more elegant, richer geometry. It means we'll focus less on just brute force math and more on designing systems that have this beautiful, natural, continuous flow. We're going to move from just bookkeeping tokens to practicing a real semantic physics.
And when you follow this all the way to the end, you land on a completely new definition of what intelligence even is. It's not about what you know. It's not about how many facts you have stored away. It's about how well you can navigate the unknown. It's the skill of moving correctly, coherently, gracefully through a world that is fundamentally uncertain.
So this whole new way of looking at things leaves us with one last big provocative question. For decades, we've been trying our best to build better filing cabinets. But what happens to the world, to our own understanding of who we are, when we finally realize that what we've been doing all along is not building machines, but learning how to cultivate intelligent ecosystems?